Alright, in this lecture you're going to learn how to use SQLite 3. So SQLite 3 is a Python library to interact with SQLite databases. So think of it as a Python wrapper of SQL code. So you can actually write SQL code inside Python using SQLite 3. You don't need to install SQLite 3 because SQLite 3 is a built-in Python library. So all you have to do is import SQLite 3. Let me test it. Script 1, yeah, it's working. Now, a standard process of interacting with a database would consist of 5 steps. First is you connect to the database. Second is you create a cursor object, and the cursor object is like a pointer to actually access rows from a table of a database. Then the third step is you apply an SQL query. So you may want to insert data in the database or select data from the table and so on and so forth. And then the fourth step is you commit your changes to the database and then you close the connection. So let's go ahead and write an example with all these 5 steps that I just mentioned. So the first thing, you need to create a connection. And you want to store that connection object in a variable. So let's say con. That would be equal to SQLite 3.connect. And what you pass here is the database file. So let's say lite.db. And if you don't have a database file yet, your database will be created by this line of code, and a connection will be established. If you have a database, a connection will be established with your existing database. As simple as that. Then you have to create a cursor object. So cur, the variable, and you need to refer to your connection and then to the cursor method, which is a method of the connection object. So far so good. Then here comes the actual SQL code. You want to point to your cursor object and then use a execute method, and then inside brackets is where you enter your SQL code. And remember, your SQL code always goes inside quotes, so you pass the SQL code as a string to the execute method of the cursor object of the SQLite 3 library. So if you're familiar with SQL, this should be easy for you. If you're not familiar with SQL, SQL is quite simple, so you'll be able to learn it quite quickly. So at this point we have a database, but we don't have any tables in the database. Because you know, a database is made of tables, and tables have rows and columns. So first you want to create a table. And a good practice is to use capital letters for the SQL keywords. So create is an SQL keyword. And table is an SQL keyword as well. And then you want to specify the name that you want to give to the table. Let's say store. That's how you order Python via SQL to create a table, but then you need to specify what columns you want, what fields you want in your table. So let's suppose we are creating a table. We have a store, we have a shop, and we want to store our products in a SQLite database table. So we would want to have the item. So that would be the item name, and the item would be a text data type. So text is like strings in Python, and then you'd want to have quantity, and that would be an integer. So how many of this item you have in your store, and the price as well. And let's say real for the price, which should be a float in Python, so a decimal point number. That's it. Here closes the quote of the SQL code, and here is the last bracket of the execute method. Then you need to commit these changes to the database. So you refer to the connection and then commit, and then you want to close the connection. So that's it. You save that and go and execute. SQLite is not defined, of course, because I have made an error here, a typo. And again. And as you see, a database was created. Now, if you run the program again, you'll get an error because the table already exists in the database. So what you could do here is a simple trick. You need to add some code in your SQL line. You say create table if not exists. So save, and if you run your code again now, nothing will happen, because what Python does is it goes and connects to the database, then it creates a cursor, and then if there is a table called store, it doesn't do anything and it goes to the next line. If there was no table, it would create a table. So it's good to have this simple conditional here inside the SQL code. How about adding some data to our empty table? Let's try that. Cur execute. So we are executing some SQL code again, and the keyword that inserts data to the database is insert. Then you want to specify where you want to insert the data. So insert into store, and what values you want to insert to your store table. So values. Then you open brackets, and inside the brackets you enter the values in the correct order. So in the order that you have defined your columns. So you'd have item, quantity, and price. And let's say wine glass. Now this is a string, so it should go inside quotes. And you should use single quotes here, because you are using double quotes for the outer expression. So if you use double quotes here, you will confuse Python and you'll get an error, so use single quotes. That's why we have different kinds of quotes to wrap around strings. So we have the string wine glass, and let's say we have a quantity of 8 and a price of 10.5. Save that and go ahead and execute. We didn't get an error, so that was successful. Now, what if we want to insert another row? Well, we could add that line in here, under this, but then when we execute the code, we would get this line executed as well. So we would have a duplicate of this row. Therefore, what we could do in this case is we would use a function to wrap around our separate SQL statements. So you can indent this block of code. If you like, you can go to edit, lines, indent, or you could use a shortcut which can be specific in your keyboard. So just look here for your shortcut, keyboard shortcut, and then you can just use that. So the reason I'm indenting the block of code is that I want to create a function here. Let's say function create table. Don't forget the colon there. And then I want a separate function for inserting data. So that would be the SQL statement for the insert function, but you can see the difference between this function and this function. Here we are not creating a connection to the database, which is wrong. So you'd want to insert these lines in here so that you establish a connection with the database, and then you correctly close that connection. So you know how to use Python functions now. Naturally, the need comes to pass parameters to your function here. So you'd want to say item, so just some variables, and quantity and price. And then you would want to somehow replace these parameters in here, so that every time you call the function, you insert some arguments, and then those values are inserted to your table. Now you can use string placeholders, Python string placeholders, to replace these values with the values that the user will pass when they call the function. But this is not a good practice, because your code would be prone to SQL injections from hackers, and that applies when, of course, when your web application is on the web. But anyway, a good practice is to put question marks in here, and then after the SQL statement, so after the double quote, you'd want to pass the variables that these question marks could be replaced with. So you'd want item, so in the correct order, quantity, and price. So let's try this out now. I would like to execute the insert function that I just created with some new items. So let's say water, glass, and we have 10 of them, and this would be less expensive. Save that and go and execute. I made a terrible error here. I wrapped with quotes all the arguments. So water glass should be in quotes and these are numbers. So save again, try it again. And your data should be now in the database. So one more time, and let's say coffee cup. Save, execute again. And now I'm sure you would want to see the data that you have been inserting in your database, in your table. So let's create a function that does just that. Let's say def view. And you'd want to establish a connection with the database. So let's copy that and paste it here. And then here goes the SQL code. So cur execute. So we always use the execute method to send SQL code to the database. And then we have quotes. Let's say we want to select the data of all the columns of the store table. So select an asterisk, which means all, from store. Alright, so we selected them, but how do we actually fetch this data so that we can use them in Python? Well, the way to fetch them is by using the fetch all method. And we want to select to store those rows in a variable. So let's say rows cur fetch all, and then we need to close the connection. So in contrast to the other methods where we were writing data to the table, here we are just selecting data, so we don't have to use the commit method. And we want to return the rows variable. And I would just like to print out the output of the function. So the output of the function is the rows variable. So I'll get the rows value printed out on the command line. Save the script, execute. Of course I have a typo here and should be return. Try again. And here are our data. So we have wine glass, water glass, and we have 2 lines of coffee cups. That's because we executed the function earlier, the insert function, and then now that I executed the script again with the purpose to get the view function executed, the insert function was executed as well for the second time, so coffee cup was inserted 2 times in the table. Alright, that's for this lecture, and in the next lecture I'll show you some more operations you can do with the database. So, talk to you later.